Hey guys, today we are continuing on with our oblique triangles and we're talking about the area of these triangles. So today we're going to go back kind of into geometry and ask ourselves, how are we going to find the area of triangles without a known base or height? So before, back when you were in geometry, you knew the formula for area of a triangle looked like this. Area equals 1/2 base times height, or base times height divided by 2. So if I'm looking at a triangle that looks something like this, that has one side of 15, one side of 13, we'll call that the base, and then an angle of 71, what I would need to know here is I would need to drop an altitude down, and I would need to find this last side. Okay, and so I'm going to call that the height. So if I needed to find this area, I already know the base, so I would know that the base is 1/2 times 13, and now I'm looking for the height, and we can use a little bit of trig here in order to find that. I would know that we have the hypotenuse because this is a right angle, and then I would be looking for the opposite side. So I would need to say that the sine of the angle 71 degrees is equivalent to the opposite side h over the hypotenuse, or 15, which would mean that h is equivalent to 15 times the sine of 71. So instead of using h, I could use 15 sine of 71, and then I could figure out the area of that triangle. And this looks very, very similar to the formula that we are given on our formula chart that helps us find the area of oblique triangles, and it's right here. The area of a triangle equals 1/2 AB sine C. Okay, and so the most important part here is that these letters are interchangeable, but this angle right here is the angle between the two known sides. So basically, we are using this formula when you know side, angle, side, that type of a triangle. So when you have a side, the angle in between it, and then the side. So again, these guys right here are all interchangeable. You just have to have a side, angle, side triangle. So let's go ahead and get an example in here. It says find the area of a triangle with the given parameters. And so they've given me an angle and two sides. So we're going to go ahead and draw that out. Ooh, that was a terrible triangle. We have ABC. So we know, well, apparently we don't know much about angle A. I didn't write that down. It's supposed to be 71 degrees. So the measure of angle A is 71 degrees. C, so the side opposite of C is 15. And the side opposite of B is 13. So when I look at this, I have a side, angle, side. The angle is enclosed between the two sides, so I can use that angle, or the formula that they gave me. So the area is going to be equivalent to 1/2 times one of the sides times the other side times the sine of the given angle. So then at this point, this is just something you throw into your calculator. Make sure you are in degrees on your calculator still, and if you typed all of that in, we would get that the area was approximately 92.19 square units. And that's all you got to do for this. So again, you have to draw your triangle out so you can tell what case you're dealing with, but my other hint for you is if you look and you see that they give you one angle, and then they give you different letters, like each of these are different letters, then that means that you're going to be dealing with this case. So if you have one angle given, and each of the things that they give you have a different letter, then you can use the 1/2 AB sine C. Okay, so that's the first way. It's kind of like a shortcut of using area equals 1/2 base times height. And if you aren't given a side, angle, side, you can always use the law of sines or cosines to find the thing that you're missing so that you can use this formula. The other formula on your formula chart is called Heron's formula, and it looks like this. So area equals the square root of S times S minus A times S minus B times S minus C. And what that S stands for, I'm going to try to make my S not look like a 5. The S is called the semi-perimeter. And just like a semicircle, which is half a circle, this is just half of your perimeter. So you're going to take all your sides, add them together, and half it. And so when you use Heron's formula, you're going to be using this if you're given all three sides. Otherwise, this doesn't work. You notice there's no angles, there's no sines, there's no cosines, so I have to have all three sides in order to use Heron's formula. So what we're going to do here is find the area of JKL, and we're going to draw that picture. JKL, side opposite of J is 8, side opposite of K is 11, and side opposite of L is 7. So this is very obviously a side-side-side triangle. So the first thing we've got to do before I use this formula is I've got to figure out what that semi-perimeter is. So if I go, and again I'm going to try to make my S not look like a 5, and if I take it and find the perimeter, so I'm just going to add up all the sides, and then I'm going to divide it by 2. So again, take your perimeter, divide it by 2, and I would get that the semi-perimeter is 13. At this point, now I can just plug everything into the formula. So the area of this triangle is going to be equivalent to the square root of all this business. So I'm going to take my semi-perimeter, and then 13. All of these letters are interchangeable. We just need to make sure we use each side once. So if we take 11, I've used 11 now. 13 minus, I've used 7. And then 13 minus 8. Okay, so be really, really careful when you plug this into your calculator. The new operating system is actually pretty cool, because if you take this and you do the square root, you're going to notice that your square root follows you. So if you have one of the older calculators, you might want to do the inside and then take the square root, do second answer, square root of second answer. But because this guy, you can see that my square root is still following me along, I can just do that. And again, you can get outside of it if you need to, press enter, and I would find that my area of this triangle is approximately 27.93 square units. Okay, so be careful with your calculator, but you can still just plug all that in and make your life a little bit easier. Okay, so this last thing that we're going to do with this application is a little bit more tricky. So we're going to be finding the area of this quadrilateral. So we have 4 sides. We can't really use any of the formulas we learned today, but what I can do is I can be sneaky about this and divide this into triangles. So what I'm going to do is divide it in half right here, so that I still have this guy going on where that has a side angle side, so I can kind of see what's going to happen here, and I can use 2 different formulas. So I've divided it into 2 triangles. I'm going to call this one triangle 1. I'm going to go ahead and find the area of triangle 1 first. And something I notice about triangle 1 is that it's a side angle side, which means I can use that first formula, the 1/2 AB sine C, and get that area figured out. So we're going to take that first formula, and my A, or just one of your sides, times your other side, times the sine of the angle in between. And so plug that into your calculator. Super straightforward. Make sure you're in degrees, and we would find that the area of that first triangle, once I divided it up, was approximately 54.16 square units. Okay, so that was the first guy. He was pretty straightforward. The second one is going to take a little bit more work, because you notice we don't have an angle, so we can't use the 1/2 side thing again, and we don't know this last side. So what I'm going to have to do is figure out what that last side is using one of my laws of sines or cosines. And so I'm going to go ahead and use the law of cosines, because I have 2 sides and an angle. And so once I plug that into that formula, and again, it's on your formula chart, we would take the other side plus the other side squared minus 2 times those 2 sides, and then take the cosine of the angle opposite, which is very nicely set up for us, so that's 37 degrees. Again, be careful when you type this in your calculator, and you will have to take the square root of both sides, but that should get you that last side. And so I already typed mine in because, you know, brevity here. So x is approximately 9.03. Now you have to be careful when you round here, because we are going to use it in a different calculation. Whoa, that was a struggle. So if you want, you could store this number in your calculator or use second answer in the next step. So if I know that this side is approximately 9.03, now I'm in a case where I have a side, so I can use Heron's. So once I have that Heron's, I need to know that semi-perimeter of that top triangle. So this is for the second triangle. And so my semi-perimeter is going to be 13 plus 11 plus 9.03, and I'm going to take half of it. And so that's going to get me approximately 16.52, And so that's the number I'm going to plug into that big giant formula. So the area of the second triangle is square root of all that business. So 16.52 times 16.52, and then I just use all of my sides, so I'd have minus 13, 16.52 minus 11, and then 16.52 minus 9.03, that third side we found. And once you type that into your calculator, again being careful of where your parentheses lie, all of that business, you would find out that the area of the second triangle is approximately 48.71 square units. And so at this point, since I know that this is a composite figure, I can just take to find the total area, I can just take A1 plus A2, and so I would get 54.16 plus 48.71, and I would find out that the area of this whole quadrilateral is approximately 102.87 square units. So what we did today is pretty much just some shortcuts for finding the area of triangles without being able to know what their base or height is. We can just use some trig functions. Okay, so I will see you tomorrow.